Well, hello, Math 3 students. Mr. Eicher here, bringing another part of Lesson 9.2 about arithmetic sequences and series. In previous lessons, we talked about arithmetic sequences, and in this lesson, we'll start talking about arithmetic series. So, if you don't have the notes, please have those ready to go. Should look like this is the part that we're on. So a series is an indicated sum of the terms of a sequence. So the main thing to know is when we talk about a series is the sum of terms. So an arithmetic series is the sum of the terms of an arithmetic sequence. So arithmetic sequence would be like this, separated by commas. Arithmetic series, you're just adding those terms. So that's all we mean by sequence. Sequence is a pattern of numbers. Series is the sum of all those numbers. Okay, so let's check out. I'd like to derive the formula, show you where it comes from. So let's say we have this sum. Now we could pretty easily add those in our calculator and we get, I think, 98. But it would be helpful if we actually had a formula that would work so we don't have to add a bunch of numbers, because sometimes we won't actually have enough information to add all the numbers. So consider this sum, S sub 7. The 7's there because there are 7 terms. 1, 2, 3, 4, 5, 6, 7. So the sum of these 7 terms is what we'd like to find. So let's take this sum of 7 terms, and let's just rewrite those terms, but in the other order, reverse order. So we'll start with 26, and then we'll do 22, and then 18, and then 14, 10, 6, and 2. Okay, so let's add these two sums together. So we'll do a little, let's see, do a little addition here. So that would be 2 of those sums, right? One of the sums plus another sum is 2 sums. And what do we get? 2 plus 26 is 28. 6 plus 22 is 28. Interesting. 10 plus 18 is 28. 14 and 14 is 28. 18 and 10 is 28. Wait a second here. 22 and 6 is 28. Hey, 26 and 2 is 28. So notice every sum that we get 28. So really, whatever that first number was, whatever that first term is, and whatever the last term is, if you add those together, you get 28. So how many 28s do we have? Well, we have 7 of them. So we have 7 of those 28s. And that's double the sum that we're looking for. So if we just want one sum, not double, just one sum, we would divide both sides by 2. So we have 7 over 2 times 28. So rather than adding all the individual terms, we could multiply this. And if we just did 28 times 3.5, we get 98, and that's the sum. But to generalize this, where did this come from? Well, 7 was the number of terms over 2, and 28 came from the first term plus the last term. So in other words, this 7 is n, this 2 is the first term, and this 26 was the last term, or the a sub nth term, the 7th term. So that basically gives us a general formula. The sum of an arithmetic series is the number of terms over 2 times the first term plus the last term. So that's last term. This is the first term. And n is the number of terms. And that gives us the sum of the terms. Now, typically, I would say to memorize this, but since your test or quiz This year is OpenNote. You don't have to memorize it, but it is helpful. The more you're familiar with it, typically you will use it correctly if you actually know the formula and what's going on. Now we could write this formula in another way. We could write it as the sum of n terms is n over 2, the first term, plus, and we have a formula for a sub n. The formula for a sub n equals a sub 1 plus n minus 1 times d. That was earlier in the lesson. So we can actually put that formula in for the a sub n term. So if we take the a sub n out that we had right here, put this formula, a sub 1 plus n minus 1 times d. Now we have a formula that we don't need the last term, but we do need to know the difference between the terms. So our sum would be n over 2, 2 of the first term plus n minus 1 times d. So that's a second formula. So maybe I'll highlight those. There's, that's not a highlighter. This is one of the formulas, and then this is the other formula. Maybe I'll put S sub n. That's not the right marker to use. S sub n. There we go. So that's one formula, and that's the other formula. So we're going to be using these two formulas for the rest of this part of the lesson. So let's check out this first question. Find the sum, S sub n, for each arithmetic series described. The first one, we have the first term, the last term, and the number of terms. So sometimes students will ask, how do I know what formula to use? And that's a great question. Which of these formulas has the first term, the last term, and the number of terms? Well, they both have the number of terms n, and they both have a first term, but the one on the left here, that's the one that has the last term. So we'll use that first formula. So the formula would be the sum equals n over 2 times the first term plus the last term. So that would be 13 times 51. So the sum of those terms would be 13 times 51 is 663. So the sum of these 26 terms is 663. Maybe I'll put a box around that one. There you go. That's how to use the formula. That's a really good example. You wouldn't really want to have to add all those up, right? If you wanted to do it the long way, you'd have to do like, hey, the first term is 58. The next term, well, I don't really know actually. What is the next term? I'd have to calculate what the next term is. I know 58 is the first. I know that there are 26 terms, minus 1. I don't know the common difference, and the last term is -7. So I'd have to go and kind of backtrack and solve this and figure out what's the last term, and then generate all the terms to be able to add them all. That seems like a lot of work. It's very convenient to use this formula. The next example, number 8, we have the first term, the number of terms, and the last term, a sub n. So this looks like it's going to be similar to this one. You have the number of terms, you have the first term, and you have the last term. So if you like to pause the video, just make sure you can use the formula. It's pretty, not a very involved formula like the quadratic formula or something. But if you like to pause and see if you can solve. So our sum would be 21 over 2. The first term is 76. The last term is 176. So 21 over 2 is 10.5. And 76 plus 176 is 252. So multiply that by 10.5 and we get 2646. So the sum of these 21 terms is 2646. The work that you should be familiar with, you should be able to do this part, show the setup, and then you can jump right to the answer. You don't have to show all that intermediate work there. All right, let's look at number 9. Number 9, you'll notice, is different because we don't know the last term. So in that case, if you have D, if we go back up to our formulas, this formula right here is the formula we'd use because this one, we have D in the formula. So let's use that. We have the, let me write the general formula out first. The sum of n terms is n over 2, 2 times a sub 1 plus n minus 1 times d. So n is 8. So we have 8 over 2, double the first term, plus n minus 1 times d. Maybe the most complicated part about this is that there's so many sets of parentheses. You have to be careful that you use your calculator right. So 8 over 2, that's 4. Double the first, that would be 6. And then 7 times negative 4. So we're going to have 4 times 6 plus negative 28. You could do really from this step. You could do all of this on your calculator, but that would give us 4 times negative 22, which is negative 88. So the sum of these 8 terms is negative 88. Now this one you actually could, theoretically, you could do this the longer way. I think it might be longer, maybe it'd be shorter. But you have the first term is 3. If your difference is negative 4, then your next term would be negative 1, and then negative 5, negative 9, negative 13, negative 17, 1, 2, 3, 4, 5, 6, negative 21, negative 25. So if we add up all of those, we should get negative 88 when we add those. Let's see, that's negative 40, negative 60-ish, negative 70-ish. Yeah, that looks like about negative 88. But I'd like to write that just to clarify. When we're doing the series, what I've written at the top is the sequence. The series would be adding all these. So really these commas should be pluses. But that's going to get kind of messy, so I'm just going to leave them as commas. But those are the terms of the arithmetic sequence that we'd like to add those terms to find the sum of the arithmetic series. Next we have D is provided, the common difference, the number of terms 18, and a sub n, 72. This one's different, right? Because in our formulas, both of these formulas have a sub 1. So you can't use either of these formulas until you figure out what a sub 1 is. So this is a good example where you're going to have to use this formula. Oops, that's not a highlighter. You're going to have to use this formula first to find a sub 1. So let's do that on number 10. Do it in green. So we're going to first use this formula, a sub n equals a sub 1 plus n minus 1 times d. So a sub n is 72. A sub 1 is what we're looking for. N is 18. And d is 7. So solving this, 72 equals a sub 1 plus 17 times 7 is 119. 72 minus 119 is negative 47. So now we have our first term. From there, we could potentially use either formula, but I like the shorter of the two formulas, the very first one that we talked about, this one right here. I like that one. So let's use that formula. So step number 2, we're going to have the sum equals, there are 18 terms over 2. The first term we just found, negative 47. And the last term is 72. So doing this all at once on our calculator, you should get 225. The sum of these 18 terms is 225. That was number 10. And then we have two more, it looks like. Number 11 and number 12, they're both the type where you're given the series, the full series, and you have to find the sum. Now, again, rather than typing this in your calculator, you'd have to figure out what all those dot, 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 dot numbers are, and I would rather not do that. So let's figure out what formula to use. Let's see, I don't know n. I don't know how many terms there are. I have 7, 14, 21, 28, and then a bunch of dots, and then 98. So let's use this formula that we started with on this side, that green formula right there. We'll start with that formula to figure out what n is. So let's do that here. So first step, number 1, we'll do the last term. Oh, let me write the general formula first, so you know what formula I'm using. I'm going to write the last term, that's a sub n, is 98. The first term is 7. The number of terms is what I'm looking for. And then the common difference is how much are these numbers changing and increasing? Well, that would be they're adding 7 each time. So the common difference is 7. And then we solve for n. So we could have 98 equals 7 plus, distribute the 7. This is going to go to both of those. So we have 7n minus 7. 7 minus 7 is 0. So then that's just 98 equals 7n. So 98 divided by 7, I think that's 14. So there are 14 terms. We can see 5 of them listed here. 2, 4, 5. So in here there are what, 9 other terms for a total of 14 terms. So now the second step, we're going to find the sum. To find the sum, I have the first term, the last term. I have the first term, the last term, and the number of terms. So I'm going to use that formula S sub n equals n over 2, a sub 1 plus a sub n. So the sum of these terms is there are 14 terms over 2. The first term is 7, and the last term is 98. So that would be 7 times 105. So 735. The sum of these 14 terms is 735. For our last example in this video, number 12. Number 12 is really similar, where you're given the series, but you have some missing terms in there. So if you'd like to pause the video, see if you could do number 12. So the first step on number 12, we're going to use this formula, a sub n equals a sub 1 plus n minus 1 times d. This will allow us to find the number of terms. So we have a sub n is the last term, a sub 1 is the first term, and then this difference is d. So we're subtracting 6, so d is negative 6. That's negative 6. So we have negative 50 is our last term, the first term 16. The number of terms is what we're looking for. And the common difference is negative 6. Make sure you use parentheses around that negative 6. And then simplifying, we would have 16 minus 6n plus 6. That's from distributing this negative 6. So that gives negative 50 equals 22 minus 6n. Subtract 22 from both sides. And then divide by negative 6. And 12. Is that 12? Yeah. Just a side note, you should always get a whole number when solving for n. You definitely made a mistake somewhere if you don't get a whole number. N has to be a whole number. It's the number of terms. You can't have 3.5 terms in a series. It's either 3 or 4 terms or some other whole number. Okay, so now that we have the number of terms, our second step, we'll use that formula S sub n is n over 2, the first term plus the last term. We just said we have 12 terms. Our first term is 16. Our last term is negative 50. So that would be 6 times negative 34. So 6 times negative 34 is negative 204. So the sum of these 12 terms is negative 204. So in this lesson, we've done several examples finding the sum of arithmetic series. I showed you how to derive 2 different formulas for an arithmetic series. So thank you for watching this video. If you enjoyed this video, please give me a thumbs up below. I hope you have a great day and that you stay safe. And please email me or your teacher to answer any of your questions. Have a great day.